Hello and welcome to another video. In this video, we're going to be working on assign cookies. And in the problem, you are a parent and you want to give your child some cookies, and you need to give each child at most one cookie. Each child has a greed factor, which is the minimum size of the cookie that that child will eat. And the cookie has a size in here. And so you can assign a cookie from S to child G as long as the cookie satisfies what the child wants or bigger. So for example, if the child's greed factor is 1, you need to give that child a cookie of 1 or bigger. 2, you need to give them 2 or bigger. 3 or bigger. And so we want to output how many total cookies we can give to the children. So in this first one, since the cookies are only of size 1, you would give a cookie of size 1 to the child who wants a cookie of size 1, and you would return 1. And in the second one, you have 3 cookies, so you can do something like give the cookie of size 1 to the child of size 1, and give a cookie of size 2 to the child who wants 2. There are other ways you could do it. You could give a cookie of size 3 to the child who wants 2, and a cookie of size 2 to a child that wants 1. But the main thing about this problem is, like, let's say we have an array of cookies and children, so let's have 2 different arrays. Let's have one over here, and let's have one over here. So what we're going to say is this will be children, and this will be cookies. So let's just have a bunch of random cookies, and let's just assume the greed factors are in order, right? So we can actually just say the greed factors are just this: 0, 1, 2, 3, 4, 5, 6, 7. I think the greed factor has a minimum value of 1 or something, I believe, but it doesn't really matter. Like, this will still be fine. It'll still work the same way. Let's say we have a bunch of cookies here. So we have a cookie of like 10, 1, 3, 5, 7, 9, 2, 3, 1, 6. So let's actually change this to 1 just to make it easier. So if we want to assign a cookie to the child 1, that child wants a cookie that's 1 or bigger. So if we assign something like 10, that would work, but then the problem is that this 10 is like very valuable, right? Because this 10 can be assigned to, it has more options, right? For example, if a child has a greed factor of 9, I can assign this 10 to that person. So kind of intuitively, you should be able to see that we basically want to, ideally, we want to give each child as small of a cookie as possible while satisfying greed, right? For example, let's just go with like some crazy example. Let's say this child had a greed of 100, and we did have a cookie that was, let's call it like 100. Well, we could give that cookie to the child that wants a size 1. That would be fine, right? But then the problem is, like I said, this is valuable. So if we do that, then this is gone. Then when we get to this one, we can't give that child that cookie, right? But if we instead give a smaller one to this one, then this is available for the child who wants the bigger one. So to give every child a cookie as small as possible, how would we do that? And if you weren't able to come up with like this part, this is what you want to do. You want to figure out, now that you know this, like, how would we actually implement that? Because we can't just like we can't do kind of like a brute force where we let's say look for child 1, and then we say like, is there a cookie of size 1, or like, what's the smallest one available? And then for this one, what's the smallest one available? And then for this one, what's the smallest one available? And so on. Because actually, kind of rarely, but actually, I think that might still pass. No. I think it's too. The constraints are too big to make that pass, or too small, which is pretty rare for an easy problem. Usually, for the easy problem, brute force passes, but for this one, that won't pass. I don't think. So we want to make this more efficient, right? We don't want to like loop through this whole thing every time. Essentially, we want to figure out like, what's the smallest available cookie, and we want to give that to the child. So the way you're going to want to do this is you are going to want to sort your children, and you are also going to want to sort your cookies. So let's just take this thing, and let's just write, instead of these numbers, we'll use some sorted cookies, right? So it'll be increasing order. So we'll still have this 100 at the end, but then for the rest of it, let's write some stuff. So let's say like 1, 3, 5, 5, 5, 5, 5, 8, 9, 100. Something like this. So basically, we just need to have an index in each one of these, so we can actually get rid of this. Move this up. We basically just want to keep track where we are in each one of them, and we need to figure out, can we assign our current cookie to the child? So if this is the cookies and this is the children, we basically just need to loop through these, and every time we can, we increment the result. So let's kind of walk through how this would look. So first we'd say, like, okay, can we assign this cookie to this child? Yes, we can, because the greed factor is 1 and this cookie size 1, so this is fine. So result's 1 right now. Then we just move both of these because we assigned the cookie. So can we assign a cookie of size 3 to 1? Yes, we can. So another one. Move both of them because we assigned it to the child. Can we assign a cookie of size 5 to this? Yes, we can. So add another one. Move both of them. Can we assign a cookie of size 5 to a child that wants 3? Yes. Move both of them. Can we assign this one? Yes. Move both of them. Can we assign this one? Let's actually change these numbers a little bit. So let's change this to 5, 5 or something. There we go. It'll still be fine without it, but this is going to be a little bit better of an example. So can we assign here? Yes. Move both of them. Now, can we assign this 5 to this child that wants 6? No, we can't, right? So this child that wants 6, we're going to want to give him the smallest cookie possible, but this one's too small. So we're just going to move this forward because this one still hasn't been satisfied. And the easiest one to satisfy is the smallest one. And because these are always increasing, you want to take the smallest one that's available and give it to the smallest person, right? That's going to be the easiest way to satisfy as many people as you can. So here, this wouldn't work, this wouldn't work, and now finally here, you can give this 100 to this person with 6. And so our total here is 367. That's kind of how you do it. You sort both of them, and then to maximize how many children you would satisfy, you always check, like, what's the smallest a child needs, and then I want to give the smallest available cookie to that, always. Because then, like, let's say there were more things here. Let's say this wasn't 100 and this was 6, and we had some more cookies, like 100 and 200 and so on. You always want to give the smallest one possible to the smallest one. That way these are left for the people who want more. That's kind of how you do it. Just sort both of them and index through both of them, and we can code it up. So we can say sort and get their lengths. Now we have an index in both of them, so we can just say we can just use I and j or something for that. And we can say while I is less than length g, which is g, and j is less than length s, which is s. We want to check, can we give our cookie? Well, let's also have a result variable. So if sj is greater than or equal to of gi, that means we can give this cookie to this child, so we'll increment our result, and we will move the child up. So the child is I, the j is the cookies. So we'll move this up, and we're always going to move the cookies up regardless. I think this is not tabbed correctly. We're always going to move the cookies up regardless, so this is always going to be like this. If we could give it, we'll give it, and if not, then that cookie's too small to give to any child, right? Because they're both sorted. Finally, at the end, just return the result. And there we go. Yeah. So I do think this is like a little bit tougher than like a super easy problem, but you should kind of try to figure out, like, I want to ideally give the cookie to as small of a child as possible. How do I do that efficiently? And this is the best way. Sort it. That way, you know, like, what's my available child, what's my available cookie, and the available child will always be the smallest greed factor. The available cookie will always be the smallest size of the cookie. And yeah, so time here is, so if this is like m and n or something, or we can just use these variables, we can use g and s. So this would be like g log g plus s log s to sort. And then we're actually looping through both of them, which will just be another this, right? So if we're going through both of them, it'll be something like this. It'll actually be more like the minimum of these or the maximum of these, but either way, this gets overshadowed by these because these variables are bigger, so this gets thrown out. So the time will be this. Space, we're not using anything. We're just using variables. So yeah, pretty easy problem to start off the new year. So, and Happy New Year to all you guys. Not New Year for me yet, but yeah, looking forward to it. So thanks for watching, and please like the video and subscribe to the channel if this was helpful.